All right, everybody. Here we go. There it is. All right, welcome back, everybody. Couple of announcements. People online, yes, I'm going to have the camera issue. It's an issue because they took the camera. So those online, if I look a little like dark in the background today, that's why. Announcements. This is the last chapter for the second exam. Second exam covers chapters 5, 6, and 7. So second exam is available to you right now. Again, 50 questions, multiple choice, no time limit, one chance. So make sure that you slowly answer the questions, don't rush through them. If you have to exit the exam and come back to them, go ahead and do that. I'm not gonna know. Just don't take 2,000 hours to complete it like somebody did. Just don't. Because it does have the time on there, and they're like, 2,000 hours, how did I get that to happen? I'm like, because you started it, and then you didn't finish it for like weeks on end, and that timer goes forever. So, all right, so here we go, everybody. Traditionally, my quickest of the 13 lectures, chapter 7, secondary storage. I love secondary storage because we need it. Every single one of us needs it, whether we save to the cloud, whether we save to our flash drives, whether we save to our laptops or desktops, we need it. Like, we need secondary storage. If we don't have that, then we can't really save files or save anything we're working on. So data has expanded from text to numeric files to now what we have now, which are video files, music files, photographic files, all types of different files we now save. As before, we didn't do all that, but now we do on a daily basis. So I've talked about primary storage before. Primary storage is like RAM, random access memory, and it is volatile. It's always changing, meaning we turn the device on, the memory starts getting used, we open up applications, the memory gets used even further, then we close the applications and the memory becomes free. Talked about that before. That's primary storage. Secondary storage is permanent storage. So that's when we're saving our files, for example, to your laptops, for all my laptop people in here. We save the file to the laptop, we save the file to our desktop, it's there. Like, it's there, we shut the device off, we turn it back on, it's still there, it's permanent. So there are several different types of characteristics when it comes to secondary storage. The first is the media type, which I'm going to talk about several media types today. Capacities, and yes, there's going to be another trick question on the extra credit today. So just like last time, which somebody already fell for in the previous one, so I hope they don't fall for it again. Different storage devices that we can save our files on. I'm going to talk about that today. And varying access speeds. No, I'm not going into exact access speeds. All right. I mentioned these before in this class, once or twice. The traditional hard disk. They're metallic platters with a read-write head that is really, really, really close to that first platter. If you shake this, or you bump it, or you hit it,
it doesn't work, yeah.
The drive crashes, non-recoverable crash. So they're susceptible to head crashes. When you think about what a traditional hard disk does, it stores electromagnetic charges. So if you type the letter A, the binary representation through electromagnetic charges is stored onto that disk. Each one of the platters has concentric tracks that run around the platter and sectors within each of those rings, so those tracks. So think about this. The larger the capacity of the hard disk, the more bytes that are packed into every one of these sectors. Keep in mind, the physical dimensions of a hard drive or a hard disk has been the same, yes, has been the same for decades now. All we're seeing now is greater capacity, greater storage capacities, but it's the same physical size. So laptops would have the 2.5-inch drive, desktops would have the 3.5-inch drive. So yes, so again, that's how we store letters, store files, that's how they're stored. And again, The larger the capacity, the more bytes that are packed into every one of those sectors. The physical size has not changed in decades. Scary stuff, right? Some of you are like, I don't have any traditional hard disks. I don't either, but we'll talk about solid state in a minute. But anyway, like smoke particles, hairs, fingerprints, any of that stuff that can get inside those platters can cause it to crash. Yeah. So what should we be doing to prevent crashes? Like what should we do in case a crash happens? What should we do before that? We should do what to our system? We got to create a what? A backup. These people are smart, I'm telling you. Previous classes put you on notice. So, just saying. So anyway, yes, exactly. We should be performing backups. I swear, if that's my camera being delivered, I don't want it. All right, so anyway, moving on. So it's disastrous when that happens. All right, the two types of hard disks I'm going to talk about next are internal and external. Now keep in mind, with internal hard disks, these are located inside. We're recording. Okay, cool, thank you. Okay, so the first type is, I don't know if that's going to mess up the stream. Should. Okay. Okay, thank you. Anyway, back to what I was saying. So the first of the two types of hard disks is the internal hard disk, and this is located inside the system unit. It is designed to store your data files, all the files you save to it, and applications, all the applications we install on it. Some people will argue that an external hard disk can do the same thing. We can install applications on it, which we can. You can install applications on an external hard disk, but it's designed to complement the internal hard disk by providing more storage space or external storage space. Of course, some of you are like, well, I can do this with solid state drives now. Yes, exactly. We're going to get there. I have to get through this part first. All right. So organizations use a bunch of different performance enhancements to make sure that they save space so that they don't have to keep buying more and more drives or more expensive drives. So they use something called disk caching, which anticipates data needs for the organization. But they also use what is called a redundant array of inexpensive disks. That's what this thing is. So that's a RAID system. And the key there is inexpensive. So if you ever see a question with the word inexpensive and you see RAID as one of your answers, you probably should check that one. But they're inexpensive. They're way less expensive than solid state drives. Solid state drives obviously cost more. But keep this in mind too. Suppose that a department has a drive that they have to access, but there's like 10 people in that department, and they're all trying to access one drive at the same time. The access speed is going to be really, really slow. But if you have a RAID system that has 10 drives, and everybody gets their own, the access speed will increase. And I want you to think about what I just said when it comes to using cloud storage. And I'm going to get to that in a little bit. Because the more and more people that are using cloud storage at the same time, the access speed is going to go down for each and every one of those people. The less people that are using it, the greater the access speed. Yes, I'm required to talk about optical disks. So if you don't know what an optical disk is, yes, we're talking about a CD, a DVD, a Blu-ray disc. A lot of us don't use those anymore because it's all digital now, so it's pretty much what we do. But keep in mind that these disks are designed to hold somewhere between 700 megabytes and, depending on what article you read, 128 gigabytes plus, that's why I put plus on there, of data. So what optical disks do is that they use reflected light to represent data. And this is going to be another one of your questions, I believe. So anything that's recorded on the disk, it's a pit. You used to be able to actually see where data was written on the disk. You could actually physically see those pits. LANs are flat surfaces where nothing is recorded on the disk. And there are three types, as I said before: compact disks, digital versatile disks, and Blu-ray disks. Those are the three types. Yes, I'm going to talk about these. So the good old compact disc, for me, it's the music CD. Music CD is what is called read-only, or a CD-ROM, because I can only do one thing with it. That's basically just consume what's on the disk. Now some of you will go, well, I can make copies of it. But that's not the point I'm getting at here. The point I'm getting at here is you can make all the copies you want, I guess. We'll get into that in Chapter 8 when we talk about the Digital Millennium Copyright Act and all that. But we'll do that in Chapter 8, or excuse me, Chapter 9. But the music CDs are read-only. So yes, we listen to it, and that's pretty much all we do with it. So it's read-only. There are some disks out there that are write once, but keep in mind the term write once. So if I have 700 megabytes available on the disk, and I write 100 megabytes to it, how much do I still have left? 700 minus 100, come on, somebody's got to know this. Oh my God. People online, what's 700 minus 100? Thank you, 600 left. So there's 600 left on the disk, but the term write once doesn't mean I can only write 100 megabytes to the disk. No. It means I can write all 700 megabytes to the disk, but I can only write to the entire disk one time. I can't rewrite it. I can't overwrite it. That's where CDRWs come in. So now we can remove files, add files, back and forth. Oh, do I get to tell that story? Yeah, I thought I'd be cool and put like all my MP3s on the disk every day, so I could go into work and it'd be a different set of music every day. But if you rewrite to that disk too many times, what happens to the disk? Poof! It gets corrupted. You can't use it anymore. So you got to watch out how many times you're writing and deleting files from these disks. All right, digital versatile disks. I was pretty happy when these came out. Very happy when these came out, because now we're talking about 4.7 gigabytes. You notice that it says on one side. Yes, there are double-sided disks, especially like if you get a DVD movie and there's like one movie on one side and one movie on the other, or there's disks out there that's the movie on one side and the bonus features on the other. That's a DVD-ROM. That is read-only. When we talk about movies that are on DVDs, that is read-only. Now, just like with CDs, there are write once and rewritable ones as well. But keep in mind that the capacities of these are way more than the CDs. They're 4.7 gigabytes as opposed to 700 megabytes. Now, something I learned the hard way that none of you are going to have to learn, because if you buy a device now that has an optical drive, it will take both DVD plus R and DVD minus R. That's what these are. So it depends on who manufactured the disc. Some are plus, some are minus. So I thought, great, I can just go to the store and buy a whole bunch of DVD-Rs, because it made sense. Now, that's not how it worked. My device would only accept the plus. So I kept burning through discs going, come on, this has got to work. Then I read the manual and I'm like, well, can't return all those blank discs, about 100 of them, so I'm like, oh well. Because I used to have a DVD recorder that could record straight from like cable right onto DVDs. It's like I could have all the movies on DVD. So yeah, I had to go back and buy a new spindle. Don't worry, everybody, I did end up using the rest of those, so that didn't go to waste. Anyway, moving on. Now we're in the Blu-ray. Well, we're in the digital era right now, but I mean, we had Blu-rays. But keep in mind, Blu-rays, great quality, much better quality than DVDs. 50 gigabytes per layer. That's why, again, it depends what articles you read on this. Up to 300 gigabytes. That's why I said 128 gigabytes plus, because some say 128 is the max. Some say 300 is the max. Companies were working on trying to create a 1 terabyte disk. I don't know why anybody would need a 1 terabyte disk. A Blu-ray? I don't know. I guess for backup purposes, but outside of that, these are great for high definition audio and video, and that's why they require so much more capacity than DVDs do. And yes, you can get spindles of BDRs. I knew they were going to come in and put my camera back during the class. That was inevitable. Okay. They keep saying that that's the higher quality camera, but that's incorrect. Okay, now, the trick question is on here for the extra credit, everybody. You see the proof? Okay, so that's gonna be the trick question, I'll get there. So now we're in the era of solid state drives. Yes, I've taken all the old hard drives in my house and we've completely added solid state to everything. So we don't have any more spinning platters anywhere in the house. And I'm gonna tell you this, I'm gonna have to knock, well, I can't knock on wood because there's no, okay, fine, there is. Okay. Okay, we haven't had any crashes since we made the switch to solid state drives for many years now. So, yes, so it works, it's reliable. There are some weird articles out there about solid state drives lasting 50 years, but let's be honest, they have not been around for 50 years, not even close at this point. So we don't really know how long data will last on solid state drives. But essentially all a solid state drive is, it's a circuit board, that's pretty much it. How fast does electricity move? You can answer this question. It moves pretty fast, thank you. I don't know what's up, people online. I don't know what's up right now. They need their coffee. So anyway, or energy drinks. Anyway, it's a circuit board and electricity moves really, really fast. Now, we also have flash memory cards, which are now getting into the terabyte range. Even for those really, really small micro SD cards. You imagine, like, even 20, 25 years ago, there was no way I could imagine that they'd ever get a terabyte onto a little dinky card. That's crazy. And then there's even terabyte cards for cameras. And yes, and GPS systems. And yes, you can use these cards to expand the amount of secondary storage space on your tablets, just like I do. I made sure I bought those cards right away when I got tablets. I'm like, I'm expanding the storage. Boop, immediately. So whenever you get a tablet, you really should think about it. Takes a micro SD card, go get one. Oh, don't get the 3, get the one that says 10. You want the one that says 10, not 3, it's faster. Anyway, USB drives, flash drives have been around for a long time now. So the 4 terabyte USB Gen 2, yes, but I don't know why you would need 4 terabytes on a flash drive. As you can imagine, these are pretty, let's see if this link works. They're pretty expensive. You know I'm gonna see if I can load it. Ooh, I'll look at that. It's only 409 bucks. Okay, so I don't know why you would need a 4 terabyte drive, but it's 409 bucks. Okay, great. Let me get back to the presentation. So, anyhow, I had a 64 gigabyte one forever until I finally decided, thanks Amazon, to get the 128 gigabyte Stealth Survivor, which I can throw across, run it over with a vehicle, put it in my laundry. It works just fine. It's a great flash drive. That did wake you up, didn't it? Okay. I don't usually throw things, but it's okay. So anyhow, they're great. The 4 terabytes. So if I say true or false, it's 2 terabytes. It's false. It's 4 terabytes. Okay. Right. Cloud computing has been around for a long time. You all know about this. I keep talking about it in this class. Just keep in mind that Google Drive, Mint, all those other places that provide cloud computing services, they're all out there. Dropbox is another one. Microsoft's got one. Amazon's got one. Apple's got one. So, just to let you know, I've been around this district a long time, and when I was the first many years, our email was not Google-based. It was, yes, on an actual server in Tempe, Arizona. And it was maintained by the IT employees that had to manage the server. So they had to do all the hardware upgrades. They had to do all the maintenance. They had to do all that stuff. But then eventually, the district went to Google. And when they did that, we now have cloud storage services. So they no longer have to maintain the servers. They don't have to do the hardware upgrades anymore. These allow for file sharing and collaboration. However, I told you this earlier in the lecture, the disadvantage is access speed. So if a lot of people are accessing Google at the same time, the access speeds are going to go down. They're going to drop. So if you ever experience like slowness at times, it's not necessarily your connection, it's the fact that a lot of people are using it. And then file security is another disadvantage. However, I think I can argue this one. I can argue this one now, especially with two-factor. Especially two-factor, multi-factor authentication. It requires us to put in codes. It requires us to, what does it ask me to do with Google? It asks me to like hit one of the three numbers. Like push the number 3 on your phone. It gives me 3 different numbers. So file security is, I'm going to argue that that's not a disadvantage now, as much now as it was in the past. I told you all this was going to be short. I'm near the end of the lecture. So, you're like, seriously? Yes, seriously. All right, so there's also mass storage devices out there. Like file servers, for example, RAID systems. I talked about RAID systems before. I hope you know what we put on file servers.
Files.
There's my smile, okay. We use organizational cloud storage, and we use network attached storage. All these together, a combination of all these is what is called an enterprise storage system. I think that's one of your quiz answers today. So that's the enterprise storage system. And of course, with that enterprise storage system, people will log into it using passwords, two-factor, multi-factor authentication. But that is what organizations use. They use a combination of these 4 things. This is not in your textbook, but I like this image because it explains what a storage area network is. So, storage area network is comprised of various servers, switches. You'll learn more about switches and stuff in Chapter 8. These are RAID systems. So everything you saw before is also in a storage area network. So keep in mind that this houses data in remote locations. This is another one of the trick questions for today. I think it's for extra credit. I think it's the true or false one that everybody gets wrong on this one. The storage area network houses data in remote locations and allows for efficient and secure access of files. So remote locations. So if I'm based in the United States and this storage area network is in Japan, I have remote access to it. I can log into it and still have access to it. So keep that in mind. The user's computer provides the file system, but the storage area network provides the disk space. So again, the purpose of this is to expand the disk space. No, you're not going to be quizzed on this, I don't think. Wait, yeah, actually, I think this is one of your extra credit answers. So yes, I talk about some more obsolete forms of storage. Some people are like, but Nick, the smaller floppy disks aren't floppy. Yeah, but if you rip the cover off of it, inside the disk is floppy, it flops. So if you rip those open, but the maximum capacity of these were only 1.44 megabytes. And I'm so old, I've taught this class for so long, that if I gave students 2 of those, my boss would yell at me. Floppy disks. Everybody got 1 floppy disk. She goes, they all get 1 floppy disk. They don't get more than that. You know how cheap floppy disks were at the time? I got a massive box at Fry's Electronics. You remember Fry's Electronics? I got a massive box for $5. And I'm like, okay, students, there's 5 for you, 5 for you. I made sure I did this while my boss was walking by. Loved doing that. I can't tell our students they can only have 1. I give them a whole bunch of them. Then zip drives came out. Those allowed us to have 100 megabytes, 250 megabytes, went up to 1 gigabyte per disk. Magnetic tape drives. I have a massive dislike for magnetic tape drives because I own one. My friend's like, come on, magnetic tape drives are all the rage. You're gonna get one. So we installed one. Only problem with that is, if you want to get a file off that drive, you have to wait for the tape to go zzz until it finally finds the file. I think it took me 4 hours once to find 1 file off that, and I said, you know what, you're an idiot. That's what I told my friend. I said, I'm going to CDs as soon as they come out. So when CDs came out, guess what? I jumped on that bandwagon. $400 for a CD burner, 2X. Yeah, but once I got that, I threw that drive at And then we also have digital cassettes, which record digital data as well. But there you go. There's your question. There's your answer for the extra credit. Because you know I had to throw that in there. Well, I told you it was going to be short today, everybody. I told you this is your fall break from me. So, the disaster recovery specialist, this is a job, believe it or not, that really didn't exist until after, 9/11 happened, and that was many, many, many years ago now. So organizations didn't really have full disaster recovery plans. They didn't know what to do in the event of certain disasters. So, especially this district, this college's district, we didn't have one until after 9/11 happened. Then, going into like 2002, we started seeing the master disaster recovery plan and where backup locations would be. So, our backup for this entire district is not at the district office, and it's not on any one of our 10 campuses. I know where it's at. It's in an unmarked building. It's in that part. Where am I facing? That's north, right? It's in that part of town, way out there. It's in an unmarked building, but that's where all of our, that's our site for, in case one of the campuses gets hit, everything is still there, everything is still running. So, and they get paid a lot of money, $120,000 a year. Yeah, scary stuff, right? But this one definitely requires that you get your bachelor's degree, at least at a minimum. Master's, some places are requiring masters. But yes, information security analysts, they do a lot of work. That is not a few hour a week job. That is a full-time job. I'd love to be one for the FBI, which I'm actually applying for that, so. Believe it or not, I qualify. Okay, anyway, I think that's it. No, one more. Remember what I said earlier about traditional hard disk capacities are getting larger and larger and larger, but the physical space is still the same? So at some point, that's going to max out. At some point, they're not going to be able to pack any more bytes onto those drives, into that physical space. So, my thing now is solid state. I know that they're going to continue to be able to make solid state drives higher and higher capacities, that we have more storage space. And if I haven't said it before, I love solid state storage because A, it doesn't generate a lot of heat like traditional hard disks do. They can't break as easy. I just threw that. Don't worry, I'll put this in the wash. I've run over it with my vehicle. It still works. The flash drive still works. So, you should all get one of those. Put it in the water, doesn't matter. But solid state storage is awesome. And that's definitely where the future is going. I know we're going to see we're going to wave goodbye to those traditional hard disks at some point. It's happening. All right. Sorry about the camera issues, everybody. They did install the camera, so now I have it. We'll do that on Thursday. All right, everybody. Told you it was going to be a short one today. Thank you for watching. Have a fantastic rest of your day, and we'll catch you Thursday for a nice, easy SimNet session.